All right, so on to the homework. Make sure you're looking on the right side of your purple page. We will be multiplying. And again, the idea is we are able to multiply radicals, if they have the same index. That's all that needs to happen. And then the radical will multiply with the radical, and the regular numbers will multiply with the regular numbers. And when I'm done and I've finished my multiplying, I just want to check rule number 3 and make sure that nothing perfect is underneath this radical. So it's going to be a two-step process. I'm going to do my multiplying, and then I'm just going to check as a second step to see if anything's perfect. So if you look, these are all square roots, and it's multiplying, so I should be able to multiply everything. And I'm going to start with number 1. So my square root of 3 and square root of 2, those are similar. I can make that the square root of 6. And if you really want to multiply this -3 with something, you could put a 1 here and make it -3 square root of 6. Now, I do want to see if there are any parts or factors of 6 that are perfect, and there aren't. I'm not going to make a factor tree on this because they're square roots, but the factors of 6 are 1 and 6, 2 and 3, and none of those are perfect. So 6 is just going to stay inside that square root. Number 3, again, if I want something to multiply with the 2, I could put a 1 here, and 2 times 1 is 2. When I multiply my radicals, the 6 and 2 give me 12, and x squared and x cubed give me x to the 5th. And now I want to go through and see if there's anything perfect. So if I run my factor program, again, I'm not going to make a factor tree for square roots. I want you to see that there is always the traditional way to do it. These are the factors that pop up. And 4 is a perfect square root. So what I'm going to do is, there's the 2, and I'm going to make my perfect set and my not perfect set. So from 12, 4 is perfect, but 3 is not. And from x to the 5th, I can make 4 of them be perfect and 1 is not. So now, joining this, the 2 will be the square root of 4, which is 2. The square root of x to the 4th, I'll use that little division trick, is x squared. And then I have the stuff that wasn't perfect, it was stuck in there. And then just going for the final answer, I can clean this outside up a little bit and make that 4x squared times the square root of 3x. Okay, so number 5, I start to see some distributing. Again, this is just neighbors meet neighbors. We know this. So first, 6 with -3 will become -18 in the square root of 3. And then when 6 distributes and meets this neighbor, I'm going to get a +18 with the square root of 2. Again, the numbers in front can multiply, and the numbers in the radical can multiply. Now, there is this whole adding rule that I want to see if I can keep adding. And I know I haven't done any examples, but just something to keep in mind. When you're adding, you need the same index, which these do have. They are technically square roots, but you also need the same radicand or base inside, which this doesn't have. Adding, subtracting is really picky. So as far as this problem goes, this one is done. And then very similar to number 7, I'm going to distribute first. I get 2 square root of 5, distribute again, and I'll get 2 square root of 10. And in order to add them, I need the same index, which these do have. I need the same radicand or base, which these don't have. So I cannot add these, and this problem is done. So now you will take over, and you're going to do the even sides if you haven't done them along the way.